All right, this is going to be my walkthrough of my practice test over concept check 2 and 3, version A. I'm going to be covering interval notation and transformations. Before we go into this test, here's some prior knowledge that I kind of expect you to know. When we're dealing with inequalities in interval notation, let's say we have a less than sign. Well, this is an exclusive value, right? We are not equal to. Can also be represented by an open hole on a number line or a graph, or an interval notation, parentheses. Additionally, let's say we have less than or equal to, that could be represented by a closed hole, and then for number lines and graphs, and then an interval notation, a bracket. That's all that I expect you to know right now about interval notation. For transformations, however, let's say we have the equation y is equal to a times b of x minus h plus k. You should know what a, b, h, and k represent. If you don't, I'm going to go over it a little bit later. I would also recommend that you have your parent function foldable out as well. That's going to help a lot with this quiz. I wouldn't recommend doing the other versions, B and C, with the foldable. I'd try to do that from memory, but for this version, I would say it would be okay. Okay, let's get started with problems 1 through 5. We are instructed to, using the graph of m of x to the right, answer the following questions using interval notation. So this graph right here, this is going to be our m of x function. Okay, number 1. What is the domain of m of x? So, what is domain? Well, what you should know from lesson 1 is domain is a set of all real x defined for a function. So that's going to be our horizontal values. The number one rule that I have even messed up myself a few times, that I see a lot of people do, is what we need to do with interval notation is we always write it from least to greatest. For example, if let's say we had -1 is less than or equal to x, which is less than 4, we would say that this is negative, bracket, because we're equal to, -1, comma 4, exclusive. We wouldn't say 4, comma -1. We always want to go from least to greatest. So knowing that, looking at our graph, we're going to read it from left to right. We always want to read graphs in this class from left to right, except when you get to polynomials, that'll be third down weeks. That's a whole different story. But for right now, you always want to read graphs from left to right. So let's see where our graph starts. Well, let's see. At x is equal to -3, we see that our function starts with an open hole. So kind of tracing this graph to the right, we have this arrow right here. This arrow is implying that this function is going to increase indefinitely to infinity without bound for x. So we start at -3. Would we use parentheses or brackets for -3? Well, we have this open hole, remember? Like on the first slide, this would be exclusive. So we would start with parentheses, -3, comma, and then where do we end to the right with our domain? Well, we don't actually end, right? This arrow is implying that we're extending indefinitely to positive infinity. So we would write infinity. And now, are we going to use parentheses or brackets for infinity? If you don't really know, think about it like this. Can you place your finger on infinity? Is it a tangible value that you can touch? No, right? Infinity is kind of like a direction. So in this case, or in every case of infinity, you would always use parentheses. Infinity is always exclusive from an interval. Okay, question 2. Where is m of x decreasing? Okay, well, when we're talking about increasing and decreasing intervals, let's think about a linear function that will look something like this. This linear function, can we agree, thinking back to our summer work, that this has a positive slope, right? Rise over run. This is going to have a positive slope, right? We're going up, we're going to the right. So in this case, this is where it would be increasing. Increasing refers to having a positive slope. However, if we had a graph like this, well, let's look. Let's look rise over run. We are going to go downwards into the right. So this would be a negative slope. This blue line would be decreasing over its entire domain, and this red line would be increasing. So if I'm asking you, well, where's the function decreasing? We want to look to where, well, from left to right, we need to be going down with a negative slope. And where that's occurring on our function is going to be at, well, we see here at -3, we're going to be having a negative slope. So we're going to be decreasing from -3 all the way to the x value of 0. So where are we decreasing? Well, that's going to be from -3 to 0. And with increasing and decreasing intervals, you always want to use parentheses. And the reason for that is, well, let me ask you this. Let's take this endpoint of this line segment right here at x equals 0. If we're excluding everything else except this endpoint, are we increasing or decreasing at this one point? Well, it's kind of a trick question. We're not doing either, right? If we're at a static point, like the endpoints of a line, we're neutral. We're not increasing or decreasing. So that's why we always use parentheses with those types of intervals. Okay, question 3. Where is m of x greater than 0? Now, I could have also asked this a different way. I could have asked, well, where is m of x positive? This is another way I could have phrased the question. So you could see it like this, or you could have been asked it like this. And I'm asking you, well, m of x, that's our output, right? Where's the output positive? So we're going to have to think above the x-axis, right? These are our positive output values. So I'm asking you, essentially, where is the graph above the x-axis? So let's think about that. Well, we can see here at x is equal to -3, we are in fact above the x-axis. At x is equal to -3, and then we stop at x is equal to -1, right? We're going to dip below the x-axis. However, that is not the only interval where your m of x is greater than 0. Look at from 4 to infinity, right? The graph comes out from below the x-axis and is now positive. The function is positive from 4 to infinity. So that would also be a interval where m of x is greater than 0. And when we have more than one interval, the way we would notate that is with this guy, this u. This u stands for union, and you'll see how we'll use him here. So we start at -3, and well, will we use parentheses or brackets on -3? We're going to use parentheses, right? Because this point is not included in our function. -3 to -1. And then again, are we going to use parentheses or brackets on -1? If I'm asking you where the function m of x is positive, are we going to include or exclude -1? Good, we're going to exclude it, right? Because if we're on the x-axis, we're at y equals 0, or m of x equals 0. That's not positive or negative. Okay, I'm going to delete this so I have more room. Or, because right, we have another interval. Or, that's where our union friend comes in. 4 to infinity. Remember, since 4 is resting on the x-axis, we exclude it, and we always exclude infinity. So that would be where m of x is greater than 0. Now, I will give you a little hint on one of the other versions. Let's say, hypothetically, this is not part of the actual problem, but let's say, hypothetically, this endpoint at x equals -3 was defined. It was a closed hole. Like that. Would that change the inclusivity right here? Could we say that then -3 is included in the data in the interval? Well, let's think about it. X equals -3, we're at +4. Is that a positive output? Yes, that would be. So then in that case, we would have a bracket on -3, but not here because we are excluding that point from m of x. Okay, number 4. M of M of 4. This is kind of an introduction to lesson 4, composite functions, when you do get there. With these types of problems, we're always going to want to start from the inside out. So M of 4. Let's think about that for a second. M of 4. What this is asking us is when x is equal to 4, what is y? Let's go look at our graph. Where x is equal to 4, what is our y value? What's our output? Well, that would be 0, right? We're on the x-axis, so therefore our output is 0. Right there. Okay, and then we could do some fun little substitution here. If m of 4 is equal to 0, we can then substitute in 0 for m of 4. Therefore, m of 4 is m of 0. And now we're just going to rinse and repeat. M of 0. When x is 0, what is y? Looking at our graph, x is equal to 0 right here. Y is negative 2. So therefore, m of 4 is equal to negative 2. So you'll see this problem on the other versions as well. Just work from the inside out, find out what m of 4 is, and then substitute that back in, then in this case, m of 0. Okay, question 5. What are the x-intercepts? Well, what is an x-intercept? Well, that's kind of, where we intercept the x-axis. That is occurring at 2 distinct points. That's going to occur right here, and then right here at x is equal to negative 1 and x is equal to 4. We always want to write intercepts as coordinate pairs. Do not get this confused with interval notation. These parentheses that I'm about to use are for coordinate pairs, not for exclusivity. So our x-intercepts are negative 1, 0 and 4, 0. This right here is a semicolon. It's just a completely mathematically accepted way to distinguish 2 different points. I also use it on my key. You could have just written both of them. I just think using this is a little more fun. Okay, that's number 1 through 5 done. Question number 6. If the water pressure acting on a diver's suit is a function of their depth below the surface, this function is strictly increasing, strictly decreasing, constant, or changes direction. So if we recall from this previous problem, we had number 2 is asking us where we were decreasing, right? That's where we were having a negative slope. So keep that in mind when we're going through this problem. I'm going to draw a very, very great drawing or a visual for this problem. Let's say we have this guy right here. This is our diver, okay? He's very happy. He's about to dive into this water. He's on the surface right now. And so if this guy is going to dive down below the water, can we agree the farther down he goes, the more depth he reaches, the more water that's going to accumulate above him, right? Because if you're swimming down, more water is going to be above you. And that water volume is going to therefore increase water pressure. So is our depth is going to increase. Don't get mixed up by me going down. Like imagine this is a depth of 0. This is the depth right here of 0 meters. Then let's say down here this is a depth of 20 meters, right? Our depth is increasing. That also means that our water pressure is going to be directly proportional with the depth below the surface. So as we increase in depth, our water pressure is also going to increase. And we can kind of see that visually on an XY plane. Let's say we have this right here. Our x-axis is going to represent the depth below the surface. And then our y-axis is going that. I'm sincerely sorry for my poor handwriting. Surface. And then our y-axis is going to be the water pressure. Okay. We're right now, when he is at 0 meters, it's going to be right here at the origin. And as we increase in depth, our water pressure will increase as well. So we'll get a line that'll look something like this. and water pressure is in fact linear with as a function of depth below the surface. And as we can see, we have a positive slope. Therefore, this function is going to be strictly increasing. A would be your correct answer. Okay, number 7. This is kind of at the beginning where I told you to make sure you know most of your function transformations. I'll review them real quick. A times b of x minus h plus k. Our a value, if you recall, I'm actually going to write this as y equals. Our a value is going to represent that vertical dilation. If a is 2, we're going to multiply our outputs by 2. If a is 1/3, we're going to multiply our y values by 1/3. And a can also represent the reflection across the x-axis. If a is negative, we're going to reflect downward. So let's think about this graphically. Let's say we have the parent function, y is equal to the square root of x. I'm not going to graph this accurately, but this is going to be the general shape of this graph. It'll look something like that. If this a value is 1 right now, if we were to make the a value -1, let's say y is equal to -1 times the square root of x, our graph is going to reflect across the x-axis, right? This is our x-axis. We reflected downwards. Okay, well, our b value, conversely, is going to reflect. Well, only thing you need to know about the b value in Advanced Algebra 2 is it's a reflection across the y-axis. The other stuff you'll save for pre-calculus. So if we then make b negative instead of a, y equals the square root of -x, our graph would look something like that, right? We're reflecting across the y-axis horizontally. Okay. Second to last, our h value. Our h value is going to represent the horizontal shift. This is not actually at all an accurate mathematical saying, but let's say we have h in this case was 5. That would be a horizontal shift right 5 units. Even though it's negative, you would shift 5 to the right. And I like to say x lies to you, which it kind of is, right? Instead of going left, you're going to go right. Like, what the heck? That's not cool. And lastly, we have the k value. K's nice. He's not going to lie to you like h. So if h is positive, it'll represent a vertical shift up. If h is negative, vertical shift down. Okay, now we can use these transformations to answer the question. Describe how y is equal to 1/3 times f of -x plus 9 is transformed from the graph of y equals f of x. Okay, let's identify our a, b, h, and k values. I want you to try that on your own to see what you get. Well, our a value out front right here, our vertical dilation is 1/3. Secondly, we have this -1 right here, multiplying to the inside of the parentheses, the x. So therefore, b is -1. We do not have a horizontal shift, so h is 0. And then k is 9. It's also important to note that h and k can be 0. Right? If you're not shifting right or left, any h is 0. If you're not shifting up or down, any k is 0. But let's say we had y is equal to f of x plus 9. What would you call your a and b value? A is equal to what? B is equal to what? With a and b values, this is what we call multipliers, right? A is getting multiplied to the function. B is multiplying. Since that's the case, a and b would have to be 1 if we don't see a different number. Because if you're multiplying f of x by 0, you wouldn't have a function, right? You just have 9. So distinguish these multipliers from these quote-unquote adders. Okay. Now we're just going to interpret what these values do in words. Well, remember, a is our vertical dilation or reflection. If a is negative, is a negative? No, we don't have a reflection, but it is a different number than 1. If a is between the absolute value of A is between 0 and 1, we could call that a vertical compression. If A is greater than 1 absolute value, we could call that a vertical stretch. But if you're like, hey, I don't want to do that because I kind of don't know the difference, or you just don't want to write that out, you could just call it a vertical dilation. So I would say that this is a vertical, I'm going to put a bullet point, vertical dilation by a factor of 1/3. I'm going to move this stuff out of the way. I'm actually going to delete that because we don't really need it anymore. Okay, next, we have a b value of -1. Remember, only thing you need to know about the b value right now for advanced algebra 2 is that if it's negative, it's a reflection across the y-axis, which in this case it is. So another transformation would be the reflection across the y-axis. And then lastly, k is 9. K does not lie to you. H is the only one that does. So therefore, this is a vertical shift up 9 units. You wouldn't just say a vertical shift up 9. Up 9 what? Up 9 feet? Up 9 kilometers? We'd have to specify units because we're talking about a coordinate plane. That would be your answer, what's in green, to question 7. Okay, question 8. I would say besides graphing, this is the hardest problem you will see from assignment 3 or lesson 3 because of just kind of the amount of mistakes you can make on this problem. And I'll point those out so that you won't make them. If f of x is equal to x minus 3 squared and g of x is equal to 2 times x plus 3 squared plus 5, write g of x in terms of f of x. What I see a lot of students do when they see this problem is they get kind of scared because they see this really weird wording called in terms of. G of x in terms of f of x. What this is really saying in simple terms is that write g of x equal to some new version of f of x. So we're going to have to transform f of x to look like g of x. So you could kind of think of f of x as the building block to this equation. We're just going to transform him to look like g. So that's kind of what g of x in terms of f of x means. Don't overcomplicate it. That's all it's asking you to do. Secondly, what I want you to do is I want you to identify your parent function. Is the parent function the quadratic, square root, rational, logarithmic, stuff like that. Looking at our functions, we can see that we have a square term. Our parents match because this is the quadratic parent function, right? Y is equal to x squared. And now that our parents match, we can now transform f of x to become g of x. So I'm going to do f of x in this green, and I'll do g of x in pink. It's going to be g of x over here, and then this over here is going to be f of x. I want you to identify, try this on your own, pause the video, identify your a, b, h, and k values for f and g. Try that on your own and see what you get. Our a value of f of x is 1. Our b value is also 1. H is 3. Remember, x is a mean liar. And then k is going to be 0. For g of x, we could say that a is 2. There's no reflection across the y-axis, so b is 1. H is going to be -3, and k is going to be +5. And now what we're going to do is we're going to compare these functions. And if we have a mismatch, we're going to have to make f of x we're going to make f of x become g of x. So let's look if we have any mix matches. We have 1 and 2 for our a values. What that is telling us is we're going to have to multiply f of x by a factor of 2. So g of x is equal to, 2. That's our a value. That's our vertical dilation. So that's what we're starting with. 2 f of, and then we're going to do our b value and our h value. Our b values right here. Do we see any mix matching between them? Nope, 1 is equal to 1. Good. H values are kind of a different story. Do we have a mix match between f and g's h values? Yes, right? F of x is at 3, h is equal to 3, and g of x is at h is equal to negative 3. And I kind of want you to envision this on a number line. I'm going to draw a number line to the side over here. This is going to be f of x. And this is g of x. G of x is at negative 3. H is at positive 3. And the reason it's horizontal is because h is a horizontal translation. If we're trying to write f of x equal to some form of g of x, ask yourself this: how do we get f to g? Well, you can kind of count by ones. We're going to go from 3 to 2 to 1 to 0 to negative 1 to negative 2, negative 3. So we're going to have to shift left 6 units. Remember, x is going to lie. So if we're shifting left 6, how we would write that is, we would say x plus 6. Right? I'm also going to put this in red. I'm trying to color code to hopefully make it make more sense. Like blue is the h value, red is the 2 for A. And now we're going to do the same thing for our k values. Let's compare f and g. Well, k is 0 for f, k is 5 for g. And I'm going to make a vertical number line here because remember, k is our vertical shift. For f, we're at 0. For g, we're at 5. It's going to be 0, it's going to be 5. How do we transform f to g? Well, we're going to shift up 5 units, right? That's going to be 1, 2, 3, 4, 5. So we're going to shift up 5 units. So on the end, we'd put a plus 5. And that would be your final answer for problem 8. Now, one of the biggest mistakes I see where marks are taken off this problem is since people look at these parent functions like, oh, x minus 3 squared, x plus 3 squared, that means that we're going to have to put an exponent of 2 right there. However, what this is really doing is we're squaring a quadratic because f and g are already defined by the quadratic function. What you're doing is you're taking this quadratic f and you're squaring it again, right? That doesn't really make any sense. So we would not put any exponent like that. And same thing with absolute value. You wouldn't do, if you, in this case we had absolute value instead of a quadratic, you wouldn't say f of x plus 6 like this. You'd have to put parentheses. Same with square root. And I kind of test those different parents on the different versions to make sure you're paying attention. So that would be your final answer right here for number 7. Okay, or 8, sorry. Problem 9. I'm going to show you 2 ways on how to graph functions. The first one is the Advanced Algebra 2 learning way, which is the 4-column method, where, hint, hint, we have to use 4 columns, which is kind of crazy. Okay, what these 4 columns are going to be, let's start with these first 2 in the middle. The first 2 are going to be our parent function table. Looking at p of x, what is our parent function? Good. It'd be y is equal to the absolute value of x, right? Absolute value right here, so our parent is absolute value of x. So let's write our table, right? Get out your foldable. You could also just plug in points, see what you get. Let's plug in -2, -1, 0, 1, and 2. If we plug in these values into our parent, let's see what we get. -2, absolute value -2 is 2, right? Absolute value always produces a positive. Absolute value -1 is 1. Absolute value 0 is 0. Absolute value 1, 1. Absolute value 2 is 2. Okay, for this left column over here, this is going to represent the horizontal transformations applied to this function, which will be represented as 1 over b times x plus h. Conversely, the right column is going to be representing the vertical transformations applied to p of x, which will be represented by a times y plus k. And now, hopefully we can see that we have an a, b, h, and k value. So, what we're going to have to do now is we're going to have to identify a, b, h, and k. So what is our a, what is our b, what is our h, what is our k? A is -2, b is 1, h is -2, k is -1. And so we're going to plug these values into these columns. So b we said was 1, so 1 divided by 1 is just 1. So we're going to have x and then plus h, so x minus 2. Okay, rightmost column, a times y, well, a is -2, so -2y plus k, subtract 1. And then now what we're going to do is we're going to plug in x for the leftmost column, y for the rightmost column, and see what we get. We're going to plug in all 5 points here, all 5 points there. So let's start. I'm going to do this in a different color, actually, to distinguish x and y's. So this is -2y minus 1. Left-hand side, we're going to plug in -2 into x minus 2. -2 minus 2, that's -4. -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. And then 2 minus 2 is 0. So all we did here was we plugged in all 5 values of x into this expression and just subtracted 2. Lastly, we have our y's. 2, 1, 0, 1, 2. We're going to plug these y values in for this expression. So starting with the top, -2 times 2 minus 1. That's, well, -2 times 2 is -4, minus 1 is -5. -2 times 1 minus 1 is -3. -2 times 0 minus 1 is -1. -2 times 1 minus 1 is -3. -2 times 2 minus 1 is -5. Okay, and what we have done is we've created 5 new coordinate pairs. So what I mean by that is this is going to be our x coordinate, this will be our y. X, Y, X, Y. So let's write those coordinates down. We have, starting with this first row, then second, third, fourth, fifth, -4, comma, -5. -3, comma, -3. -2, comma, -1. -1, comma, -3. And then 0, comma, 5, -5. And now we're just going to have to plot these points onto the xy plane to the right. So -4, -5, left 4, down 5. -3, -3, left 3, down 3. -2, -1, left 2, down 1. -1, -3. And then 0, -5. Now, we're going to connect the dots. We're going to add arrows to the ends of our graph because p of x is continuous across its entire domain. And then, just for extra, you can also label your function. This is p of x, and that would be your graph of p of x. Now, there's also another way you could do this. It kind of requires a more in-depth knowledge of these transformations, however. So I'm going to delete this graph right now, and then I'm also going to delete the points. And ignore this work, to ignore the 4-column work. We're just going to look at our parent function graph and then p of x. So like we've said over here, our parent function would look like -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And now what we can do is, if you recall from Algebra 1, that the vertex of this absolute value function would be at h comma k, right? So we're going to go left 2, down 1, right? X lies to you. So x plus is really left 2. So left 2, down 1, that is our vertex. Now we have this a value. Remember, with the parent function, our a value is 1. That's why we go right 1, up 1, right 1, up 1, right 1, up 1. We're reflecting downwards, so instead of going right 1, up 1, we're going to go right 1, down 1. And remember, a is our vertical dilation, so we're going to have to multiply our outputs by 2. So output's vertical, so instead of going right 1, down 1, we'll go right 1, down 2. You can kind of graph those points. Right 1, down 2, right 1, down 2, and you could really do that till the end of the graph. And we also have to graph the other symmetrical points. Left 1, down 2, left 1, down 2, left 1, down 2. And there you go. Connect your dots, add your arrows, and that is our p of x function. So either do the 4-column method. I'm not too sure how Ms. Weissman was going to enforce that for y'all's class when y'all are in it. We didn't have to do that on our quiz. It's still really good to know in case she does make you do it. And yeah, that's about it. Just make sure you know how to do this as well as understanding what I just did. And yeah, that's really about it for graphing. If you have any questions, please let me know. I'd be happy to help. Thank y'all for watching.